rough diagram, sir. It will take more time. Okay, the moment I'll close, what will be the in rod? So in okay, this at least rod. Let me show it. It's needed. Yeah. Now come for this. This is the EMFE capacitor. So initially it was at rest, no. So therefore a current I1 will flow. I'm trying to analyze the circuit. So therefore charge Q minus Q. Then because of this current I1, tell me what will happen to the rod. It will experience a force BI1L. It will start accelerating. Then as it starts moving, how do it will behave? It will behave like a cell and it's having a resistance also. So the next part, initially this what happens. The moment you close switch, this what happens. The rod will start moving towards right. It's having a mass M. It will move towards right. Then after, okay, let's write all the moving rod. How do we'll put it? This moving rod. So I should give polarity no for this. So there should be B bar and this one. So it will have the moving rod will behave like a cell. This having a charge plus Q minus Q E. This EMF, there's a R, and the total resultant current, let it be I. So how the BIL force, the resultant BIL force must act here. So there are two currents are there. So let me take the resultant, this one. It will accelerate. Let V be the velocity. Fine, all of you. I think a student has to analyze once. So I'm just bringing capacitor, cell, and also the resistance. All three, let me place it at one point. Okay, let's write a loop equation. So what is our question? The charge on capacitor after a long time. The charge on capacitor after a long time. I'll write the loop equation plus C minus Q by C minus C minus IR equal to 0. What is I equal to? I should be equal to dQ by dTR. So this will be E minus EMF induced. So what is EMF induced? We'll write BLV. Motional EMF. But sir, capacitor is there. Let it be. I think till here, no problem. What we have to find out, we have to get expression for charge as a function of time. That is our target. Okay, somehow I have, so E is a constant, C is a constant, B, L, okay, Q, DQ, DT. So that's V has to be eliminated. The only thing is what I should try here now. So what to do with V? I'll take help of this. I think I'll give 1 minute time. Okay, please do think. Tell me how to further proceed. Yeah, somebody?
mdv by dt is equal to BL. From there will.
Yeah, that's all. So here, there's an important idea of the problem. MA is equal to BIL. So this will be M dV by dt equal to B dQ by dt into L. So this will be M dV equal to BL into dQ. MV equal to BLQ. So this V I am going to replace. I think please do remember they're really going to help us a lot. So substituting this now, E minus BL. So in place of V, I'll write it as BL Q by M minus dQ by dt R equal 0. I think it's not purely, it's an integration based problem. One plus B square L square or this will become E by R. So there's everything. If you want, you write it. Okay, we'll simplify. M plus B square L square C square MC MRC it will come. So now I think, can you integrate this and get expression for as a function of time? Then put t equal to infinity, you'll get the charge at any instant of time.
Option.
Anybody?
Without integrating also we can do, sir. At infinity dq by dt equal to 0, we'll get q directly.
Dq by dt 0. So that we have to replace.
Option I will get.
Option A, yeah, fine, yeah. Okay, some resistor, capacitor, and also a cell. At any instant of time, if they ask you current, all this is going to help you a lot once you get a charge. So any of other conditions, they can ask you. What is the speed of the rod at any time? Because once you get a charge, you can bring the speed of the rod. So many things are there. So first you get as a charge as a function of time, then all other things can be determined. So even this, you can see speed of the rod, what is the acceleration of the rod? So many things can be asked here. Okay, what about energy conversion? Work done by cell is equal to increase in elastic potential in capacitor plus heat generated in the resistor R plus, okay, there's only heat, no? Yeah, this will be increase in kinetic energy of the rod. Okay, fine. Look at the, so what's happening to the work done by cell? A part will be converted to increase in elastic potential of capacitor. It will be generated across the rod and also increase in kinetic energy of the rod. I'm writing mv square R. So this you can write it as.
Sir, work is done by BIL.
Okay, try to think.
Work done by BIL force will be equal to change in kinetic energy.
The role of BIL is such that it will make that energy available across capacitor in this one, no? So in almost every numerical we brought like this. So here also the same thing. It's like a force which will convert that energy from one form to another form. That's the role of BIL. Huh?
Sir, so that thing also should be mentioned here.
Not here. So that is the work done by BIL only. What happened will available as different. See, this is the role of BIL. Is see like a, what BI1L does here. What is BIL does here?
Accelerate.
So you mean to say work done by BIL here? Tell me, where do that work done by BIL will go?
LHS, sir.
Huh?
Work done by BIL will result in change in kinetic energy. That is the only force acting on that part.
No. Other things are there, no?
No other force is acting.
No, don't think in terms. So it's a, why you are thinking in terms of force. So tell me like a, who will convert energy of the cell into these things? You are messing up things here. Okay, now straight away takes very simple. If there's a rod having a resistance R, I'll release it. Tell me what will happen to the rod. Go back to the basics all. Now you have to analyze with the basics. Now if I switch on the source, current will flow. So BIL force will act here. This having a resistance.